In this session, we are going to talk about what is recursion and what are the various containers in which we store data. So let's start with a warm-up session, which we already know. Basically, what is recursion? Recursion is the process in which the function calls itself. It is used very widely in many algorithms like merge sort, quicksort, trees, graphs, dynamic programming, etc. So this is how a basic snippet looks like. Basically, we do competitive programming in Java or C++, but I recommend mainly C++ due to its intense library features. Here, the hash include bits std contains almost everything. We write mm, iostream.h, mat.h, all the header files, which is not necessarily required. A single thing known as bits std c++.h contains everything in it. Suppose we need to maximum function to find the maximum of few numbers. So what we need to do is we basically write a function and try to find the maximum of two numbers using the function, which is a waste of time. Using bits std c++.h, write maximum of a comma b, just the maximum number which we want. Similarly, this we can find minimum, GCD, and many more. Bits std c++.h contains many containers like arrays, vectors. It contains input output like C in, C out, and almost anything without need to use other header files. So it just reduces a lot of code. And this is basically how a boilerplate code of C++ looks like. So let's see a function. This is how a function looks like. Here it's the say hello function, and in the main method we are calling the say hello function. When we call the say hello function here, it returns hello. So we are trying to use using the functions now. Using recursion, we using the function say hello and void say hello. Number of function is calling itself. In the main function, we are calling the function say hello.
Sorry for the interruption.
So hello prints a number of times.
Shivram, we are seeing the same slide. Yeah. Okay, fine.
Now, did it change?
Yes, it did.
Now, is it okay?
Okay, done.
The function just keeps on calling itself. There needs to be a base case to stop this infinite recursive calls. So let's say they say hello 10 here. It calls itself 10 times, as we have say hello n minus 1 in this say hello function written over here. It goes till 10, 9, 8, 7 till 1 and becomes 0. But without a base condition. It keeps on going till hello minus 1, minus 2, minus 3, minus 4, minus 5, so on till infinite recursion. This is where a base case comes here. Base case stops the recursive call after a certain condition is met. Let's see here. If n double equals to 0, it just stops. So there would be a 10 to 1 times hellos printed, and when it doesn't let it go negative values. So that's how a base function is used. We did a lot of examples like how to find the sum of numbers using recursion, sum of digits using recursion, factorial, a lot more too. We can use to write a program using for to print patterns like this, like 1 2 1 2 3 and so on. We can use recursion for this too, but the time complexity would be more for it. But doing this way, it's a simple way than using many for loops. So what's the time complexity for a recursion? The time complexity would be 2 power n times its exponential, because the function keeps on calling itself many number of times. Many tree-like structures use recursive calls. We will learn master theorem, recurrence relations, which call them which keeps on calling the function recursively. So it takes a lot of time, mostly exponential. For example, Fibonacci series is n and n minus 1, n plus n minus 1. So there's f of 6 here. So there's f of 6 minus 1 is 5 and f of 6 minus 2 is 4. So it calls on f4 minus 1 is 3, 4 minus 2 is 2. It keeps on calling recurse till it reaches 0. No, it reaches 1 or 2. Now we are going to the what is HTL? HTL means standard template which we are using for a language. We use linked list, trees, graphs, all the data structures. We implement them using arrays. We implement queue using linked list and all. But there's no need for writing a program to implement them. We can simply use them using the bits std C++ function here. It's a header file, as we discussed. What are the benefits of HTL? You can write shorter codes that run faster. The pre-written codes in HTL are extremely error-free and optimized. So now let's learn about various HTL standard temporary language which we are going to use here. These are all the templates of vectors. Vector is same as an array, but it's dynamic in nature. Array we in the beginning itself, but vector there's no need for defining it in the beginning. We can it's changed dynamically during the program. We need to give some values which are need with changes, or we need to insert them or delete them. So we use a vector for this. It has advantages when compared to arrays. It's used simpler to an array. How do we implement an array? We use just int a. Similarly, we can use vector like this: vector int v. This is how a vector looks. It stores all the elements. These vectors and everything arrays, these are containers which are used to in them. Vector int v of 10 elements of integers in it, and vector char v 10 comma h stores 10 characters. So vectors have other functions when compared to arrays. They are pushback. Pushback function inserts the value to the end of the vector just like it erases the element which we inserted at the end. Clear erases all the elements, and v dot size returns the current size of the vector. There are many use cases of vectors. Given n input and print all the integers are in sorted order, we can sort the vectors too. By sorting, we write a program like sort, bubble sort. There are many sorting techniques, but using HDL, we can just write sort a comma a plus n. Let's take an array of size a, which contains some 100 elements. Let's give some 100 elements in them, and we can just write a single statement known as sort of a comma a plus n. Here in the beginning, a means the starting element and a plus n means the ending element. This a is iterator. We are going to talk about iterators more. So what's the importance of vectors? We can insert them and delete them during the execution. They can be used to push elements, pop elements. No need to write separate code for that. No separate for loops needed. You can just use a function pushback and pop. We can clear all the elements too. We can find the size of a vector using v dot size. Sort function. This is how a sorting happens in vectors. It takes bigger of analog and time to do it. So here's vector int v and string is, and we sorted, using v dot begin and v dot end. These are the iterators. V dot begins means the starting element and v dot ends means the ending element. For an array, we use a comma a plus n, but in vectors, we use v comma begin comma v comma end. Similarly, for string, let's take a string of size a to z in reverse order. Let's say z and everything in reverse order. So we just sort. Let's take the string as is, and we sort it as s dot begin and s dot end like this. Here, it sorts is the entire string would return a to z in a sorted order, perfect sorted order. Take some other string which you want, and it would return the string in a sorted order. So what's a pair? Pair means two data types. It's used to relate between two data types. Any of the data types we can mention like this: pair of int comma int, pair int comma string, pair. We can use pair in pair itself, pair int pair int comma string, pair vector int string. In here, it's a pair of vector of int and string. In here, it's a pair of int and a pair of int and string. Pair string comma int. Here p comma first prints the hello and p comma second prints 6. So the string part is hello. So and the it part would be 6. We have a lot of data types. We have a input given in which the inputs are string as well as integer values, and we need to find a relationship between them. Suppose those both are related with each other, that string and a particular number. To associate the number with that string, we use pair. Sorting arrays vectors of pairs. We can sort pairs too, but let's take a pair of integers here. Pair of two integers like p of 0 is 1 comma 2, p of 1 5 comma 2, p of 2 8 comma 1, p of 3 1 comma 0. And p of 4 3 comma 4, and let's sort this. Sort of p comma p plus 5. So it sorts the pair in this increasing order. 1 comma 0 would come first. Let's consider this as ith element, this is jth element. We see we first keep the ith element which has the lower index first. So all the ones are kept first, and next 3, 5 and 8, and the jth elements. The jth elements are 0, which is the next smallest thing, and 2 and 4 and 2 and 1 first. It depends upon the ith elements and next on j elements. Now let's talk about iterators. Iterators we saw before is we're using s dot begin, s dot end, a comma a plus n, v dot begin and v dot end, right? Instead of writing the whole code many times, we can just use a keyword known as auto, and we can use auto. It equals to v dot begin. It stores the address of the first element, and we use star dot it to print it. And to go on to the next thing, we just increment the value. Similarly, if we want to go back, we decrement the it. It prints the current iteration we want, just like I. Instead of writing v dot begin every time, we use it, it's iterator. Similarly, we can use for arrays too, using pointers. Now let's talk about sets. Set is a container which doesn't allow any unique copy of elements to store in it. We represent set as the other representation set it is. It contains all the elements which are integers in a set format, so no duplicate elements are allowed. And of string of a set. Let's consider some strings which are stored in a set which can't repeat again. We insert elements in a set using insert. S dot insert, it pushes the element into the set. S dot erase, it erases the value from the set. S dot count, it counts the element in the set. Suppose we are giving elements like A, B, A, D. The count would be 3 as A is already repeated. S dot clear, it cleans the entire set. And s dot size, it returns the current size of the set. We use a iterator for this, but we don't use it in form of an array like s of 0. Set iterators, we use the auto function as mentioned before, auto it equals to s dot begin, then increment iterator decremented, and we find the position of a set using the iterator. Now let's talk about functions related to set iterators. List find returns the iterator to element with value x, returns n if not found. S.bound returns iterator to the first element which is greater than or equals to x, returns s.n if not found. Returns iterator to the first element is greater than x, returns s.n if not found. Releases the element with iterator it. Let's use the find function. Find function used to find the element. If the element is found, it returns true. If not, it returns false. S dot find of the x is the element which we need to search. Lower bound, it returns the lower bound, and upper bound, it returns the upper bound. Map. Map is a container in which elements are stored. Suppose there's a word known as there's a string, and we need to know the occurrence of characters in a string. Or there are many strings like apple, banana, ball, and everything. We need to find the occurrence of specific characters in them. For that case, we use map. We can think map as a special array which indicates keys of elements, can be native or big or even strings. They can be similar to Python dictionaries. Map, key data type, value data type, M, map, string, int comma M. This is how a map looks like. We can issue a key to a particular element in the map. Let be a string or string. Any other data types, any two data types or multiple data types, we can use a map. We can use map within a map too, just like how we use in a pair. So M of hello equals to 50 here. Hello is the key and 50 is the value. And M of world equals to 12. World is the key and 12 is the value. Using key, we find the value. If we are printing M of hello, it prints 50, and M of world, it prints 12. If we give a value which is not present, it would just not print anything, and elements, only positive ones, are need to be given in maps. No negative elements are allowed for integers. M dot clear clears a map. M dot M of key, value of elements within key. It finds the key. We use the iterator as map M dot first and M dot second. M dot first is used to give us the key value, and M dot second uses the value in which the key is holding. M dot count of key, M dot find of key, M dot errors of key. Okay. M dot count of key gives the count. How many keys are there? M dot find of key is used for finding a specific key which holds a value. On M dot erases a particular key, so the value too would get erased. Examples of map we using string and double, and m auto it equals to m dot find of a name here. It finds the name. So let's see how a map is represented for an array. We use I equals to 0, I less than n, I plus plus for a map and pair and everything. We are using iterators because it is taking the values and it is checking the values. It's retaining the values. It updates a few values in them. It changes the values. It takes a few values. It doesn't take a few values. So values will be changed and there would be only a few values left. For that reason, we can't take it from 0 to n because there would be some values missing or some values gone lost due to the conditions as it stores only a few values. For that reason, we use iterators. Auto it equals to s dot begin, it not equals to s dot end. It equals to s dot begin means it stores a starting element. Let's see the set. For example, the set. We are giving a few values. It takes the values, but it removes all the duplicate elements, and we perform some operations like delete, erase, and everything. So few elements get lost. To keep track of that, we use a iterator. It keeps track of the beginning element as well as the ending element. Auto it equals to s dot begin, it not equals to s dot end, it plus plus. This works for all three set, map, and vectors. Vector int v for int x to v. This is a simple loop. Instead of writing int I equals 0 else then in I plus plus, we just use a iterator int x and v, the container's name, and set int s for int x is to s, map int m pair int xv, store first and store second. First returns the key value and second the value. There are some other containers known as queue, stack, deck, priority queue, multiset, and ordered set. So, what's a multiset? For a set, let's introduce elements. The elements we are introducing it. Suppose, as according to the property of a set, we can't give the same element more than once, but we need to, due to some problem, we need to write element more than once. So we are using a multiset. In multiset, it takes the element which is given again. The suppose this 3 3 3 in a set. The number of if we find the number of elements, it would be only one, as three can't be repeated. They can be only once. But if we keep a multiset int of s, we can give it three times or any times we want. Just the use of a multiset. It can store duplicates. Queue, stack, deck. We are going to learn about them now. What's a set? We are inserting the value into the set. Inserting 3, inserting 2, inserting 5. So it would be a stored count of 3. So how many elements of 3 are there in here? Only one. How many elements of 4 are there? 4 is not given a single time. 4 is not even inserted. So it prints 0. We stored a list of 3. So 3 is gone now. And we have only 0. I stored instead of 4. So 4 is inserted now. And a stored count of 4. There is one element inserted. This is how set is represented. Set in S 2568. These are the elements of set given here. If we print the size, it gives us the 4. As there are 4 elements here, we are using the auto function now, the iterator x, and s is a set which shows the elements 2, 5, 6, 8. So we print them and it prints 2, 5, 6, 8. Here, the example which we said before, we insert a value of 555 in a set and we count it and we get the output as 5. As it contains no duplicate element, it gives the count of 5 as 1, same as multiset, which can allow duplicate values. So 5 times and gives the count of 5 as 3 instead of 1. Now let's look at map. Map string int. String is the key and int is the value, and m is the variable which holds the map container in it. So m of monkey equals to 4. Let's initialize m of monkey equals to 4, m of banana equals to 3, m of hexacore equals to 9, and we print m of banana. Here it returns 3. These doesn't make a lot of sense now, but when we need to use, there will be problems in which we have to solve. We can't solve them using arrays. Using arrays it becomes a lot difficult, so it's more simpler and more faster to use these maps, sets, queues, stacks, periodic queue and everything. It reduces a lot of code and makes it simpler for us. Here auto x iterator in m x dot cout x dot first and x dot second. X dot first gives a key value, x dot second gives the value stored in the key. Now let's come to queue. In queue, we insert elements from the array side and delete elements from the front. So we are pushing the element 3 and we are pushing the element 2 and we are pushing the element 5. So in a queue there are 3, 2, 1, 5. We are printing q dot front. It prints 3 as 3 is the front element and we want to pop the element. So the first element would go and we are printing the first element again, so it would be q dot front, it would be 2. Now going on to dq, we can index, we can insert the elements in the front or in the back. Push back of 5 is pushing the element from back, so we can insert elements at back or front. So 5 is inserted and push back of 2, 2 is inserted, push back of 3, 3 is inserted. So the elements which are inserted stay in the beginning. So we want to pop back, it just pops it back. We can insert the for the back which we want, but in a queue we can insert it only at the back. In a deck we can insert the element from back or front and delete it from front or back. It does follow the rules of a normal queue, but it has its own operations to perform operations simpler, to reduce the code and everything. Stack stack is used to serve first in first out. We insert the element goes to the bottom, we insert our other element, it goes on top of that element. If we want to remove the element which we inserted at last, pops off. Using that principle, we use stack here. We push a element 3, we push a element 2, we push a element 5, and we want to find the topmost element. So what's the last element we pushed? It's 5. So it prints the topmost element 5 here and pop. It pops the element 5. So there would be 2 and 3 in a stack. So we want to print the topmost element now as of top. It prints to priority queue. Priority queue is similar to queue but has some conditions in it which gives a particular priority. We tried such as we want all the descending elements. We want the elements in descending order or ascending order or somewhat like that. Q dot push of 3, Q dot push of 5, Q dot push 7, Q dot push 2, Q dot pop. So let's compare how priority queue and a normal queue works. Q dot pop, Q dot top gives us the maximum element instead of giving us the element which we pushed right now. There's 2. Instead of giving 2, it gives us 7. Because 7 is the increasing or the biggest element there is. And we pop the element, Q dot pop. It pops the first element, which is the largest element. So they would be in order like this: 7, 5, 3, 2. We are popping the element. So 7 would be popped. And we find the top now as 7 is popped. 5 would be the topmost element. And we are popping 5 too. And after 7, 5, we are popping 5. It would be 3. 3 would be the topmost element. But here we are inserting 6. So it would be 6, 3, 2. So there will be 6, 3, 2 elements. If we find the topmost element, we get 6. Now we are popping the element. Similarly, we can find for mathematics too, we can use many algorithms. We can find prime numbers. There are many cases. Suppose we want to find a greatest common divisor of two numbers GCD. We write a big program for that to find it. We first find the LCM, and from that we find the greatest common divisor. Or let's take we want to find the GCD of two numbers, GCD of a comma b. There's a simple formula for this actually. Let's take GCD of b comma a. We can find it using GCD of b comma b modular divided by a. What does this do? It reduces the element a lot. It reduces the size of the second element, which is b comma a. A would be b modular divided by a now. So the size would be reduced a lot. And finally, the result would be the greatest common divisor, which we get. That's b modular divided by a would be the greatest common divisor till it reaches the zero part or the smallest element. That's how we find the GCD. But that's a crude method. Just don't need to write a big GCD program for that. This is a simple method, but there's a most simplest one out there. We need to keep a double underscore GCD of a comma b. That's enough. Not for writing GCD of b comma a mod b in a function and keeping a case for that it's b is not equals to 0 or something. So double underscore GCD of a comma b gives the greatest common divisor of a particular number. In this manner, we can find the number of ones in bits, number of zeros too. Number of ones can be found using built-in functions, and the parity too can be found using built-in parity. which we'll talk later. There are many uses of bit C++.h. These are the uses, and there are mathematical cases in which we can use this too. We need to find the factors GCD, and there's a special way to find the prime numbers, all the factors of a numbers. We can reduce the time complexities in this manner. So in an interview, they ask us to write an algorithm. We write it, we get it correct, of course, but they ask us to write that same algorithm which we wrote in a more efficient manner. So let's try to write an algorithm in an efficient manner. Let's try to solve a problem in an efficient manner. So there's no need to solve the problem again and again. So they need to understand algorithms to solve a problem properly, to reduce the time complexity, space complexity, to solve it much more in a better way. So if we solve a problem in a better way before they ask, it reduces a lot of time for us. There are many competitive programming platforms like CodeChef, CodeForces, in which you can practice. Create an account there and participate in online contests. Forget about rating and stuff. Rating and stuff would come eventually, but our main goal must be improving. You're not interested in competitive programming, it's alright, but you heard of LeetCode and HackerRank, where there are many company related interview questions. One can practice them and understand the basic data structures like clinical lists, queues, trees, and many algorithms which are needed. There's a competition known as ICPC. I request all the colleges to form teams in a 3 member team or 4 member team to participate in ICPC and represent. There will be regionals and finals. It's a competitive programming based competition. Its finals would be held in various countries, so we get to meet top programmers country wise. Thank you.
Thank you, Shivram. It's a great session.
Okay, thank you.